Hello, how are you? Hope you're doing good. So, today we will talk about the redox reactions. So, this is a term used in chemistry. Redox basically means it is made up of two like initials of two different terminologies. The first one is reduction, second one is oxidation. So combined, they are known as redox reactions. So to start off with an example, rusting is a redox reaction as iron metal is oxidized to iron ions by losing electrons, and oxygen in the air is reduced to oxide ions by gaining electrons. So we will discuss now in detail what happens in a reduction reaction and what happens in an oxidation reaction. There are several definitions of oxidation, and reduction. So the most common one is the oxidation is gain in oxygen or a loss of hydrogen. So let me write it here. The definition for oxidation is oxidation is gain in oxygen or a loss of hydrogen. So this is the definition for oxidation, and reduction is exactly the opposite of oxygen. That means it is loss of oxygen and uh, or gain in hydrogen. So from these definitions, we see that reduction is the reverse of the process of oxidation. So any combustion process is classified as oxidation as it involves gain oxygen. For example, if we are burning an oil, and if we are burning any gas or coal, so for example, the burning in the burning of methane gas, the formula for methane gas is CH4. So when we are burning it in the presence of oxygen or in the presence of air, the chemical equation is like this. The methane gas plus oxygen is converted into carbon dioxide, CO2, and some water vapors that are known as H2O. So when methane burns, the carbon atom in the methane, this atom, the carbon atom, this one, and I'm going to show this with a different color. So this carbon that is marked as blue color, basically this carbon in the methane gas, it gain oxygen to form the carbon dioxide. So this carbon, basically it gains this oxygen to form CO2 gas, the carbon dioxide gas. And therefore, we can say that this carbon is basically oxidized. So, alternatively, you can think of methane as losing hydrogen, which is again oxidation. Basically, initially, this methane gas, this carbon was linked with four hydrogen atoms. So, it lost four hydrogen atoms and it gained oxygen. So, in, if we consider it both ways, so, so the carbon atoms lost some hydrogen and gained the oxygen. So, which is again oxidation. So, substances which help oxidation to take place are called oxidizing agents, or they are known as oxidants. So in this reaction, of course, the oxidizing agent is here the oxygen, or the oxygen present in the atmosphere, or oxygen in the gas, oxygen in the air. So that itself is an oxidizing agent. So, but substances with lots of oxygen in their molecules can also act as oxidizing agents. Sometimes it is not necessary that oxygen itself will be present for oxidation. There are some compounds which have a lot of oxygen molecules, oxygen atoms in their molecules. So those types of substances or chemical compounds can also act as oxidizing agents. Substances which help reduction to take place are called reducing agents, or they are known as reductants. For example, let me write another chemical equation. So this is copper oxide when reacted with carbon monoxide in some certain conditions, it is converted into copper plus carbon dioxide gas. Now we have to identify which substances went under the oxidation process and which substances went under the reduction process in this chemical equation. So here the copper 2 oxide, this one, the copper 2 oxide is being reduced. So how is that? Because this copper oxide actually it loses oxygen. Copper oxide has lost an oxygen atom. So when anything loses oxygen, it is said to be have been reduced. But this carbon monoxide, it actually it gains this oxygen atom because initially it had one oxygen, but finally after the reaction it had two oxygen atoms. So this carbon monoxide is oxidized. So copper oxide is reduced as it is losing oxygen, and the reducing agent here is carbon monoxide, because reducing agents or reductants are the substances which help the reduction to take place. So as it is gaining the oxygen, so it is acting as a reducing agent, and as copper oxide is basically losing an oxygen atom, so it is said to be an oxidizing agent. So an oxidizing agent would be reducing itself, and a reducing agent would be oxidizing itself. One of the very common example in which the redox reactions or the reduction oxygen reactions is the restoration of old paintings. So the restoration of old paintings is done by means of an oxidation process. So most old oil paintings are basically lead-based paintings. So these become discolored over the years due to the reactions with pollutant gases in the air. In particular, uh, with the hydrogen sulfide gas. The formula for hydrogen sulfide gas is H2S. So the lead-based oil paintings, so they kind of lose their color. The oil paintings, they kind of lose their color uh, over a certain period of time. So this reacts with the lead ions to form black lead sulfide. So this hydrogen sulfide basically it reacts with the lead present in that oil-based paintings to create lead sulfide. So this lead sulfide is basically a black colored compound. So this black color is actually causing the discoloration, or this causes the painting to lose its color. So the original white color or the original color can be restored by repainting with an oxidizing agent such as hydrogen peroxide. So if we recolor that painting with a oxidizing agent, that is hydrogen peroxide, the formula for hydrogen peroxide is H2O2. So if we recolor an a discolored painting which has lost its color over a certain period of time, so if we color it with recolor it with H2O2, so that would be converted into that would be converted into the, sorry, we have to add a plus sign here. So when H2O2 is reacted with a black color lead sulfide, so the products are lead sulfate. Lead sulfate is basically white in color plus 4H2O plus water. So the black color lead sulfide, which was created over some time after the painting got discolored after being reacted by the pollutant gases like H2S in the environment. So this lead sulfide is converted into lead sulfate. Lead sulfide is of black color, lead sulfate is of white color. So again, this by using this technique, we can restore the color of the paintings. So redox reactions are those reactions where the reduction and oxygen are occurring at the same time, that are known as redox reaction. And sometimes it redox is written also like this with an O being capital because it represents another word. So when we look at most oxidation or reduction reactions, we find that both processes are taking place at same time. Consider passing hydrogen gas over heated copper oxide. This is just an example. Here the black copper oxide is reduced to pink copper. However, the hydrogen is oxidized to form steam. Let me write the equation for this example. So basically, what is happening here is the copper oxide or CuO is heated and hydrogen gas is passed over it, and the products are copper and steam. Steam is basically the water being water at a higher temperature is steam. Basically, this is created when we pass hydrogen over a copper oxide. Copper and water, the steam is created. So, in this reaction, the copper oxide is reduced because it loses an oxygen to copper, and the hydrogen gas is basically oxidized to form steam as it gains an oxygen. So we call such reactions as redox reactions. When looking at such reactions, it is best to think in terms of electron transfers. Basically, all of the chemical equations, they would not be involving, or they would not be dealing with directly the oxygen atom or the hydrogen atom, because there are several chemical reactions in which oxygen and the hydrogen are not directly linked. So we have to think in terms of another definition, that how we can generically, what definition can we use for any uh, reduction and oxidation reaction, because every reaction is going to be either a reduction reaction, an oxidation reaction, or a redox reaction. Most of the reactions are redox reactions. So we have to think of another definition that covers the scope beyond the loss of and gain of hydrogen or oxygen. So for such kind of definition, we have to think in terms of electron transfers, because in every chemical reaction there would be some kind of electron transfers. So the oxidation is a loss of electrons, or in other words, an increase in oxidation state. We will discuss these terms uh, later, that what is an oxidation state and what is meant by loss of electrons. So the second thing is reduction. Basically, the reduction is a gain in electrons, or a decrease in the oxidation state. So it is best to express the redox reactions in terms of ionic equations, because when we write the ionic equation, we are going to write the electro, uh, electronegativities, or the charge the charge which will be changing on each product, or each atom of the chemical reaction. For example, with copper oxide and hydrogen, the chemical reaction that we have just discussed, the copper ions have gained electrons, and the hydrogen atoms have lost electrons. So let me rewrite that equation. Basically, what happened is the copper oxide, in presence of hydrogen gas, this is H2, it got converted into the copper plus steam. Steam is H2O. So if we write it in the ionic form, so what happened is the copper basically has a charge of +2, and has a the copper and oxygen have ionic bonds. And if we just go into the minor details, or the atomic details, basically what happens is this copper has a +2 charge, oxygen has a -2 charge, and with the charges being balanced, they just stick together because the positive copper attracts the negative oxygen and they just make a ionic bond. So this copper, the copper +2, basically what happens is the copper +2 is converted into copper, simple copper, and this copper do not have any charge on it. So in doing that, it must gain 2 electrons from somewhere. So when the copper oxide, the copper from the copper oxide, when it gains 2 electrons, it will become the neutral copper, in which there would be no charge existing on the copper atom. And the other reactant was hydrogen. So as hydrogen had hydrogen gas and is bonded through covalent bonds, so there is no charge, there is zero charge on the hydrogen gas atoms. But when it reacts with the copper oxide, it basically forms steam. And the ionic formula for steam, because the water is also bonded through ionic bonds here, in which one hydrogen, the positive hydrogen, is bonded to a negative hydroxyl ion. Hydroxyl ion is OH ion. Combined, it has a negative charge. So as the charges are balanced, +1 is balanced by -1. So an ionic bond is created between hydrogen and this forms basically the formula of H2O, in which there are 2 hydrogen and 1 oxygen atom. So basically what is happening here is the zero charge is being converted to plus 1 charge. The +1 means it has lost an electron. The -1 means it has gained an electron. So in this case, when hydrogen gas is converted to steam, what actually happening is it is converted like this, and an electron is produced. So this electron is basically utilized, or that is used by the copper +2 ions. So this electron is basically this electron is gained by this copper to form copper atom. So this is how this cycle goes, in which the hydrogen is basically oxidized and the copper is basically reduced. So the overall ionic equation is this one that I have mentioned here, in which change for hydrogen and copper both are shown. So another type of redox reactions are basically displacement reactions. There is no need to remember the terminology here. Just the definitions for reduction and oxidation would be enough. So the displacement reactions, these occur when a more reactive metal displaces a less reactive metal. For example, in a displacement reaction, what is happening is there is a compound named copper sulfate. So this copper sulfate is converted, the zinc, it replaces the zinc metal, it replaces this copper from here, and as a product, zinc sulfate is created ZnSO4, and as copper is replaced by zinc, so it will exist now in this form. So before moving further, I would like to show you a video for redox reactions. Let me open that video. Just a second. You share. So now, yes, it is showing now. So along with this video, there is another one that shows the displacement reaction. So reaction between zinc and lead sulfate. So this is an example of a displacement reaction. Let me start this video that shows how the zinc replaces the lead nitrate. So yes, here is a video, small shorter version. So the zinc is added in the solution, and this metal bar is initially made up of, sorry, this is the zinc metal, and this in the solution we have added the lead nitrate. So the lead nitrate, the lead from the solution is basically, as you can see, this is forming the hair-like structures. This is basically the lead, because zinc is replacing the lead, and the lead is just creating these small hairy surfaces. So this is the before and after. Initially, it looked like this, but after the reaction, it is covered with the lead atom, because lead is replaced. The zinc replaces the lead in the solution to form the zinc nitrate, and the lead atoms are basically stick on the surface of that metal. So let's get back to our lecture. Displacement reactions also occur when more reactive non-metals displace less reactive non-metals. For example, there is a reaction between chlorine and potassium bromide. The reaction, it goes like this. Chlorine gas is reacted with a solution of potassium bromide, KBr. The formula for potassium bromide is KBr. So as a product, potassium chloride is formed, and we get bromine as another product. Basically, what is happening here is this chlorine actually it replaces the bromine to form potassium chloride. So in this reaction, the chlorine, which initially had zero charge, it gets converted into an ion of charge -1, and it sticks to the potassium with +1 charge. So a new bond, ionic bond, is created between the chlorine and the potassium. And initially, this the bromine bonded with the potassium had a negative charge, but at the end of the reaction, the bromine liquid now, because it has a covalent bond, so it is now converted to a zero charge. So as we can see now, the chlorine it actually gained electrons, so it is reduced, or it has gone under the process of reduction. But the bromine in the ionic bond present in the potassium bromide, so it kind of lost an electron to form bromine liquid with a zero charge. So it kind of went under the process of oxidation. So this is the overall equation of this chemical reaction. So as well, just to quickly revise, so oxygen is the gain in oxygen, and reduction is the loss of oxygen. Oxygen is loss of hydrogen, reduction is gain in hydrogen. So initially this definition was sufficient, because the scientists thought that every reaction that involved the gain in oxygen or the loss in hydrogen was known as reduction or oxidation reactions. But later they had to change the definitions, because every chemical reaction did not involve the reduction, or sorry, the gaining or losing of hydrogen or oxidation. So they changed the definition to oxygen being the loss of electrons, and the reduction being the gain of electrons. So it is often helpful to identify the redox reactions by the color changes involved. So when using various oxidizing and reducing agents. So oxidizing agents, as we have studied, are the electron acceptors. The reducing agents are basically electron donors. So non-metals are good at accepting electrons. For example, chlorine, bromine, they all are good at accepting electrons. So they act as oxidizing agents. So metals are good at donating electrons. For example, potassium, sodium. So in most of the cases, they act as reducing agents. Potassium iodide is also a reducing agent. Carbon, hydrogen, carbon monoxide. These are also examples of reducing agents, or they are known as electron donors. So another example is acidified potassium manganate solution, that is a powerful oxidizing agent. This is because the manganate ions are good at accepting electrons and therefore they help oxidation. So I am quoting many examples just to so that uh, at the end of this lecture, the intent of the lecture is clear, that what are the oxidation reactions and what are the reduction reactions. So the final example is acidified potassium dichromate solution is also a powerful oxidizing agent. So the dichromate ions become reduced to the chromium ion. The color change is from orange to green. So we can have several tests for to identify the change in colors and what is happening in the redox reactions. So that's it for redox reactions. We have learned about a redox reaction, what is oxidation, what is reduction, what is an oxidizing agent, what is a reducing agent, and finally how we can conduct some tests for oxidizing agents and how we can conduct some tests for reducing agents. So it's kind of a little late here now. So I will see you in the next class. Take care. Bye.